Cool.
We're all new to this, so be gentle with us. We've not a clue what you want or what you need.
Oh, we've read what they've sent us.
We can
Well, that really makes two of us. So yeah, this is my second year kind of volunteering at Spaceport. I got a lot of hands-on knowledge with the guys that go out there. It's a lot of the people I launch with pretty regularly. Last year I kind of helped, or past 2 years, I helped out with pad management, kind of the safety reviews, that sort of thing. And this year, because of all the additional teams, they're like, hey, can you do all the safety reviews ahead of time as well? So I'm like, sure, I'll fit it in somehow.
Yeah. And I know, I feel your pain. I'm doing a lot of safety reviews for 24 universities for a launch month after next in July in Scotland. So I'm going through all this. So I'm on the other end of it.
Yeah, so luckily I only got 4 teams this round. And y'all were the first for video interview. So thanks for setting it up. Thanks for taking the time. Really excited to see what you've put together so far. Pretty much what I've been told and what I'm looking for is your rocket going to be safe to fly for the competition? So we kind of want to look at where you are, what you have left, if anything, and then kind of go from there, kind of step by step through the whole rocket, all the components, the flight. I know your reports have been pretty detailed and spot on, so I don't think it'll take too long and we can get through this. But I'm using basically that same form that I sent y'all that has Ezra at the top. I know it's a little blurry. But yeah, basically just that checklist. So kind of want to, I guess, start from the exterior of the rocket, and then we'll get into the nice innards. But let's start with the nose cone and work our way down.
Okay. There's mud on it. Yeah, there is a bit of mud. There we are. So it's metal tip, fiberglass. Again, fiberglass.
All filament wound.
Yeah, filament wound.
Nice long coupler. How's the tip attached?
It's screwed in from, I probably won't show on the video, I'm afraid. From down there, there's a screw for it.
All right. Did you use any Loctite or anything to keep it from untwisting?
We will put some on, but we're intending to use that screw mounting point for an eye bolt for our recovery arms. Yeah. So we'll be replacing the current screw that's in it with a 1/4-inch eye bolt and Loctiting it in.
So that's a commercial off-the-shelf nose cone. They've not manufactured the nose cone.
Right. Yeah, just make sure you have Loctite's a good way to do it, but make sure everything is really nice and seated there so it doesn't untwist. Is there anything that's going to be attached to the nose cone, or just that mounting point itself?
Just that mounting point. Or were we intending to potentially put some additional mass in the nose cone on that, mounted to that bolt as well?
Yeah, we probably will.
There'll be some additional mass.
Mass.
In the nose, but that's. Yeah.
Do you know about how much mass?
So we'll vary it on the day based on weather. Is the idea, but it won't vary.
But what would it roughly be?
Won't be that much.
It won't be that much.
It's not for stability. It's just for the precision.
Yeah. So honestly, it'll vary from about.
Gotcha. Kind of alter your target altitude.
Yeah, it all depends on the wind and
and the temperature and everything.
Temperature, humidity, and all that. Oh, they're all into it.
That'll work. Yeah. The more mass that's up there, of course, the bigger potential for that screw kind of backing out. But I think you should be all right with a little bit of Loctite. So that's going down into the
swivel as well, aren't you, on the connecting cable? So there's a swivel on that as well, so that'll negate some of the twisting motion.
Okay. Yeah. Do you know what that swivel is rated to, force-wise? I know the nose cone doesn't have much mass, so.
They're not. I can't remember. They're 1,000 pound, 2,000 pound.
Yeah, they're usually about 1,000 pounds rated to.
Yeah.
Yeah, that's fine for the nose cone. That'll work.
But it's only as strong as your weakest link.
It'll be one of them.
Telling everyone.
Reasonably sized one. It's about the size of my thumb. So it's
a
biggish swivel.
And then walk me down the next airframe section that connects to.
All right. That one.
Yeah. So it'll be cardboard and then it's pre-glass.
There's nothing in this, but this is just glassed over cardboard, and this will just be empty with just the parachutes in it, and then our avionics bay riveted into the bottom of it.
Okay. So everything is from the nose cone is going to pop off. It's going to separate there.
Yeah, it's separating at the joint between the nose cone and this tube.
Okay.
Then-
Do you have anything holding it in place until separation, like shear pins or?
With friction fitting.
I think we hadn't made our mind up yet. We were thinking potentially just friction fitting it, or maybe using some
shears.
1mm shear pins.
Yeah. I think
Yeah.
the test is with friction fitting, and it's what we've flown on before.
Yeah.
So I'm quite happy with.
Yeah,
friction
when
fitting, to be honest.
we've launched on this airframe before, and we friction fit last time, and it worked perfectly fine.
What altitude and speed was that test flight?
That was to 3 kilometers in metric.
And one.
So
And
one
again,
max.
around the same altitude and 1.1 max, so faster than we're expecting to go
yeah.
at Spaceport.
Yeah.
Okay. Do you have a pressure vent hole in that section at all?
We're gonna drill them. I don't know. If
Yeah, well, there's a few holes tapped to various places already, but probably need to put another one in the middle.
Yeah, I think we're doing 3 mils per section.
3 3mm ones.
Yeah. Not as of now drilled, but we've done.
Yeah. At the competition, we'll kind of double check your friction fitting with a few different people, make sure everything feels right. That shouldn't be too big. How does the coupler, you said it attached with rivets? Can you explain that part?
Yeah, so we've got some big, like, plastic rivets. They're the kind of thing people use for car body panels and things. So there's just 3 holes tapped into the avionics bay coupler, and those go in, and you tighten a screw into them, and it splays out the teeth on the rivet. So that can't pull out until you undo the screw, and then that's just stops the. And then they're never really under that much force because
it's holding the tube.
Yeah, there's rods. This will be the out bay. It's really long. There'll be rods that go through this metal rods that the eyebolts will attach to. So that should take a lot of.
The only thing the rivets are really doing is stopping this falling off of the out bay whilst it's descending on a parachute.
As long as the rivets are stronger than the nose cones held on, it'll be fine. Injection charge goes, it'll take the nose with it. Yeah. But I think we've got some ground testing to do yet, haven't we? It's they're in middle of exam term now, so it's quite difficult to get together to get the black powder because it's all different laws over here with black powder. honestly, it's so hard, such hard work.
Oh yeah. Yeah, I'm also helping out a team from Turkey, and it's some of the different laws are crazy.
Oh, it's mad. It's well, when we get to the end, there's some questions I want to ask you about the igniters.
Yeah, definitely. So we'll skip the coupler and we'll come back to that later. Let's go to the lower airframe.
So that is same type of airframe as before, but we have you can see that there's a firewall in here with a slot through it for the shock cord to pass through.
Okay.
So the shock cord's connected to the bottom of the AV bay, and then we'll be connected to an eye bolt that's threaded into the top of our casing. But there's just a firewall there to reduce the area that we're pressurizing to make ejection a bit more reliable.
Gotcha. And how's the fitting on that? Is it also going to be friction fit?
Yeah. So again, we're potentially thinking about shear pins, but current plan was to friction fit that as well. Because that's going to be the main chute in there. We might want to put shear pins in that because that does have to hold together as we bring tension across the drogue.
Conventionally, I mean, I assume you've been in rocketry for a fair few years. Convention usually dictates that you split it in the middle, bring it down with a small drogue, and put the parachute out the nose cone.
We're going to switch around.
I think we also
the way they're putting payloads in, etc. They're putting the main out of the bottom, so the nose cone doesn't really need the shear pins because it's not going to get knocked off because your drogue is going to come out of the front.
Yeah,
so thinking behind it.
So I think
the team I'm flyer record for a few years, they've done that in the past, and it's very tricky to keep the main in there and from deploying. Recommend some friction fitting, but definitely shear pins.
Yeah,
I've always definitely preferred shear pins because friction fitting, you could have one fit, you go to a different temperature, humidity, and it can change. I'd say cardboard's less of an issue with that. So
it's phenolic tubing, isn't it? So you do get a bit of swelling.
No, it's cardboard with fiberglass.
Oh right, you changed from phenolic, didn't you? You went to fiberglass. Yeah. So Yeah, I think we were going to go with shear pins. Was it
Yeah.
two milli shear pins or something like that we were going to go for?
Mm.
But
I
there
think we
again,
have-
we need to do deployment tests to
Yeah.
make sure the shear and everything.
Yeah, there's definitely a lot of force there. I guess we'll get into recovery after we get down the side of the rocket. So show me the bottom of that tube. What does it connect to?
So then that tube rivets into our fin cam, which is a bit of a mess at the moment because we're halfway through carbon skinning all the fins.
No worries.
That has got, so there's a phenolic motor tube, 3 5mm steel threaded rods running through the entire thing, expanding foam between three 6mm centering rings in it with expanding foam between them all. I don't know if you can see down the end, but there is fiberglass port. There is a chop strand and fiberglass and epoxy poured onto top centering ring for bit of reinforcement.
Okay.
Is that milled fiber that I gave you?
Sorry.
Is that milled fiber that I gave
Yeah,
you?
yeah.
Milled fiber. Yeah, it's fine milled fiber that goes in with the epoxy. It just gives it a hell of a lot more strength.
Oh yeah.
Yeah, and then fins are 6mm birch ply wrapped in a layer of 125 grams per square meter carbon fiber
We need to fix that.
that we haven't finished
Yeah, it's not
lacquering
finished.
yet. Needs some finishing.
No worries.
It's been specially designed, that finish, for an aerodynamic drag.
Mm.
Hey, it works sometimes.
Yeah. Seen
Right,
golf
I'm gonna-
balls.
Something
It's the
slim.
same principle as a golf ball.
Yeah, look at a whale fin. That's a fun one.
True.
How big are your centering rings? What are their thickness?
They are 6mm.
And how many you have in there?
3.
3. Yeah, that's good.
And then it's foam fill between it as well. They
Yeah.
fill through. So when they put the foam in, the foam's interlocks it all as well. It's not squirty foam. It's 2-part expanding foam.
Yep,
So
yep.
it's stuff that, God, years ago, we used to sell it now. Can't remember now. Years ago. Magnum Hobbies, I think it was. They used to
Yes.
sell it. Going back a bit.
I think mine probably doesn't work anymore because it's probably 10 years old, but I've used it on a few projects a while back.
Yeah, it does. I like it because it interlocks the fins and gives you a nice substantial thing. It also helps with the fins as well. But,
It does, and it's really cool how you can vary the density just by adding a few drops of water and changes it drastically.
Yeah.
Let's see. So we got fins. What about motor retention?
Motor retention. Do I have those bits?
The
Who's got
plate.
plates?
About the plate. We can just show him the back. And
You could. Do you want to talk about the back while I see if we've got the plates? You explain it, and I'll see if we've got
Yeah. So the rods, oh my god, they go all the way through. They come out on this side, and then it's really spiky. There is a metal plate that sits on this. This is flush with the outer body tube and the phenolic motor tube. Then it goes the actual motor casing and the thrust ring on top of that plate. There's another plate on top of that just to keep it from moving at all. That's the idea.
A metal plate.
Yeah, they're the metal plates, and they sit on and they push against
I haven't
the
got
outer
the
body
plates,
diameter.
Yeah, it's basically a metal thrust plate they've got on the bottom. So it's pushing the load through the motor mount and through the airframe as well to distribute the load of the motor.
That's it, yeah.
Let's see. Also exterior. Tell me about your rail buttons or rail guides.
We have 2. I think they're 1515 rail buttons. Yeah, and they will. One of those will sit just above the bottom centering ring, or in the bottom centering ring.
Yeah, it's in the ring. They're all in the ring.
Right. So the bottom. Yeah. So the lower one will sit in the bottom centering ring. We'll drill a hole, pour some epoxy in, then screw it in, and then the top one will sit on the firewall in the
bottom tube.
Bottom longer tube.
So they're all reinforced points.
So they're at some bulkheads.
Okay.
Yeah, they're going through the bulkhead basically as close to the center of mass they can get it to. So
perfect. Yeah, we've definitely seen way too many of the rail buttons pop off on the pad at Spaceport, and that's just that's a long trip for nothing.
yeah, we've got to. I mean, These guys have flown. They've come on a lot because they come down to our local club. Not that we've got many in the UK. There's only like 2, isn't there? 3 at the most, where we can actually fly. But we always say go through a bulkhead or something so you can put a longer screw into it. It's not going to pull out.
Exactly.
So,
Perfect.
it's all been beaten into them.
It has.
So tell me about what's inside your coupler, all the electronics.
Okay, so we have actually with some questions on this. It's a Cat's Vago and a Easy Mini. So they're both just COTS, flight computers. And the Cat's Vega, both systems will be dual redundancy, different batteries, different switches. Yeah, it's all different circuits. And then it's two chargers for both main and secondary deploy. And then the Cats is also our GPS as well. And I think we're using just 9 volts. And then we've got the 9-volt hoarders that are recommended.
Shall I grab some electronics?
You can go pull up them.
I think the Easy Mini is currently buried in an outbay on a different rocket.
Don't worry about it.
It'll take me 10 minutes to dig out, so I'm going to not get that.
Yeah. You get the Vegas.
You don't like lithium polymer batteries over there, do you?
No, so there's no lithium.
Personally, I use them in all my rockets, but we have had a few at Spaceport catch fire and make a mess.
Well, if it comes in, it will make a mess. But I mean, they recommend that you put them in a metal case, but surely that's just going to make it worse if it gets punctured. You're going to end up with a bomb in your rocket, aren't you? It's just going to overpressurize and.
I think carbon splinters in my fingers.
Yeah, it's more just if you're going lithium, try to stick with a commercial one or something that's recommended. But
but then you've got the hassle of making a metallic box for it to go in, etc., etc. Didn't you say you're going for nickel hydride batteries? What were you going for in the end? Or have you just got
using 9 volts?
9-volt alkali batteries.
9-volt alkali. And then this is like the hoarder for it. It's why it was recommended on the documentation.
Nice.
Well, I'd say if you're using the 9 volts, do a test because you're going to be on that pad a while, maybe. Worst case scenario, isn't it?
So, Colin, these are the ones we flew this at. So when we did the 2-stage, we used these computers.
Right.
Yeah.
But I do a drain test. We
can do that.
The problem because before they were using lithium polymers and they did the tests on that. Now they've changed to 9 volt.
Yep.
You don't want us to use them. Put them in metal boxes. What you'll have to do is do a test for at least 2 hours. Would you say?
Yeah.
Jason?
Honestly, I would do more.
Well, do more than that. But your electronics might be running, but you need to see if it'll fire your deployment charges after that length of time, because it might have enough power to run your electronics, but not enough to fire your charges. So you need to do something along those lines.
To give you a good example, at Spaceport, the winds are very unpredictable, and most of the time after 10 o'clock in the morning, they're already pretty high, and the launch windows can go in and out. So let's say if you get your rocket ready to launch, you come back ready to launch it, then the winds pick up above our 20-mile-an-hour threshold, and they might not drop for 2 or 3 hours. And if it drops, we're going to launch as soon as we can. But we want teams to be able to tell us, okay, we've been sitting on the pad, let's say 2 hours. We can't launch anymore. We have to scrub and take it down.
Mm-hmm.
Yeah.
Okay.
Right. I've wrote some notes down here, so I'll have a chat with them afterwards when we're all finished and everything. So I've got a few little ideas on that.
Cool. Can you show me the inside of your coupler with any electronic sleds or how everything's going to mount to each other?
So it's not currently made at the minute. I can tell you what we're going to do. It's just going to be laser cut plywood, basically. So we'll have a sled that will have, I think, just 2 rods that will run through the entire tubing, and then
3 rods or so. 3 rods.
3 rods, and then they'll go to. There'll just be a century ring on both sides that the rods will go through. Will bolt on.
And they've got aluminium reinforcing plates on them.
Yep, plates on top of that. And it's just going to be a sled. The switches are standard screw switch, I think, recommended by whatever the documentation was. And it's quite
Alrighty.
simple. It's just a screw switch, a battery, and then a flight computer for each one. And there's holes in both centering rings for the chargers, the wires for the chargers.
The bulkheads.
Yeah, for the bulkheads.
And what were the bulkheads made out of?
It'll be 6mm ply.
Okay.
Basically.
The loads coming through the threaded rod. So
Into the alley plate.
To the other side.
basically, you've got your shock cord going to the fixing on the top of that. Load goes through your threaded rods and then to the fixings on the other ends. So basically, that's just hanging in the middle. It's not really taking any load.
Right.
The bulkheads have just got to survive the ejection charge pressure.
Which all threads are you using? What size?
Sorry, what was that?
For the coupler, what size all threads are you using?
They're going to be 5mm steel threaded rods, I think.
Alrighty. And what about your attachment points on those bulkheads?
I think those will be 6mm forged eye bolts.
5mm forged eye bolts.
Can you get 5mm? Every time I've looked,
Well, if you're using 5mm all thread, you need to put 5mm eye bolts on it, don't you?
Oh, right.
No,
The rods, the eye bolt doesn't connect to the rods. The eye bolt's just
right, okay.
alley plate. So there's one 6mm hole in the alley plate and 3 5mm holes.
Oh, right, okay. So it's the bulkhead is birch plywood and an aluminium.
Yeah.
Yeah.
Neglected to mention that.
I said that
Well,
at least.
we
twice.
said-
Gotcha.
Yeah. What thickness is your
And-
alley plate?
It is some 2 3 mil.
2mm, 3mm.
3mm. Yeah, 3mm.
I think they're in
Yeah,
the house,
3.
by the way, is it?
Are they?
For those eye bolts, what do you have to prevent it from twisting or unscrewing?
We'll put some Loctite on them as well. Probably just 2 nuts and then some Loctite.
That'll work. Yeah, make sure when you get to the competition, all of that's applied, all of that's really nice and tight. If we'll definitely try to unscrew it by hand. If we can, then we'll ask you to fix it. But that should be good. What else? I would like when you do finish your av bay, I would like some pictures of it, especially how everything is mounted to the electronic sled, and then any wire connections, especially anything that's soldered or whatnot, just so we can double check, make sure we don't see any weak points anywhere. Let's see. Let's go on to the recovery. You said you're putting your drogue out at apogee and then main at a target altitude.
Yeah.
All right. What's that target altitude?
It's 300 meters above the ground. I think that's
When you're talking
900.
to America now, you need to know.
I know.
About 1,000
things
feet.
are in
Yeah,
feet
that's
and
1,000
inches.
feet, I'm afraid.
No, I'm good. I work for a German company, so it's back and forth between metric and standard all day long. I wish we could just switch. It'd be so much easier.
No, you'll never switch.
I don't think our government would let it.
No. I used to work. I worked in California for about 5 years in engineering over there, and some of the drawings, like metric and imperial, on the same drawing.
Yep.
Like, whoa,
Yep.
no.
Yeah,
That's
all
a
of our
big
parts.
disaster.
All of our parts are designed in metric because we're a European company, but all of our hardware is standard SAE hardware, and it's you got to be careful on your units. That's
Yes,
for
you
sure.
have.
What about your recovery harness? What are you using for that?
So you've got the shock cord.
Yeah.
So it's 1-inch tubular nylon, and it's
Yeah.
4,000
So-
pounds rated.
Yeah. 1 inch with 3 lines of reinforcing stitching. And that one's 5 meters long, and we've got a 10-meter long one as well. And then the lines to the chutes. This is the drogue, but the main's the same. You've got big barrel swivel, heat shrinked to some, I think, several quite thick lines. These are all COTS parachutes. They're kind of nice ones. They're strongest stuff we could find.
You got any fire protection for those nice
Yeah,
parachutes?
Yeah, fire
We've got
blankets.
fire blankets to wrap those in while they're packed.
Nice.
Yeah.
And then for the recovery harness, the nylon, how does it attach to the rocket?
So that it's got stitched ends on it. So we'll just like thread it through the loop and then thread it back through itself. So it's just all there's no knots or anything in it. It's pulling on its own. It's got to tear the loop out to come free.
Is that commercial stitched when it came with it, or?
Yeah.
Okay.
Yeah, so that'll just go.
It just
through the eyeball.
negates the possibility of anything happening with us. Say if you put a quick link in there or something, then that's another failure point. So if you're just using that, you're getting rid of one of the failure points.
100% agree on that.
Yeah.
I try to not use quick links, but sometimes you do.
Yeah.
What else? So for popping your drogue out at apogee, there's going to be a lot of force trying to pull your main section apart. Do you have any way to, let's say, bundle up or reduce that shock loading with your shock cord? A lot of times I will wrap the shock cords into small sections and put some really nice tape on it.
Yeah,
so that
frangible links.
Yes.
Yeah,
we
we were going to do that. We'd used that with the little two-stage rocket we flew the other weekend, and that worked really well. So we'll be doing that again, I think.
Yeah, we'll refill the lines.
Yeah, I would definitely highly recommend that with your setup. I've seen it be the difference between popping your main out and not.
Yeah.
It just helps with the deceleration.
Right.
And reduces the loads on a lot of things.
Let's see. I guess let's go over your payload. What do you have plans there?
So the current plan is to do like a flywheel spin stabilization thing, but not on the way up, purely as like a test of electronics and hardware. So it's in the top half, and it will descend on the drogue and the main, and it will deploy on the way down, purely to try to stabilize. Turn on. Sorry.
It'll still be inside the rocket.
Yeah, so it's all in the rocket. Nothing's getting deployed, and it will stay in the rocket, and then it'll turn on the way down. So nothing's happening during flight. And the simple idea is it's just a metal disc and a PID system.
It's a CubeSat with some big metal discs in it.
Yeah, it's a CubeSat with a disc in it and some PID, and then a battery and a switch. And it will try and a flight computer, and it will try and measure the spin, and then try give it some torque and try to counter the spin. That's the idea of it.
Okay.
So it's basically
how is it a
wheel? What do they call it now?
Flywheel, reaction wheel?
Not a mass wheel. It'll come to me. Carry on.
reaction wheel?
Reaction wheel. That's what I was thinking of.
Yep.
Jason.
I know.
His laptop needs to be facing directly.
How is it attached to your rocket?
It will be bolted. It'll be bolted to the top of the payload bay of the av bay. So I've just thought actually our eye bolt for the drogue chute's going to have to be attached to the top of the payload, not the top of the.
Well, okay, I think there's some questions to have here because, obviously, the payload needs to be completely removable, and the rocket needs to be flyable without the payload. It still would be. We'll just put the eye bolt in the centering of the payload, opposed to the av bay, opposed to the payload.
We just have to move the eye bolt.
Just move the eye bolt down. I don't know if that is allowed in the rules, or if that counts as flyable by itself. The other option is we just we pin it through the walls basically, or we attach it. That's basically the two options, I think.
Yeah, to my knowledge, the requirements are it has to be removable. Now, it doesn't state that it needs to be removable in a specific amount of time or anything. So if it's something that is removable but takes a certain amount of time, I don't see that as a problem.
It shouldn't even take that long. It's just shifting the eye bolt up, basically. It's just moving the eye bolt connection point.
Yep. Yeah, because it has to get weighed separately, doesn't it? And
yes.
Yeah, but it doesn't state it has to be deployed, does it?
No, and ours is not
payload.
No.
All very up to interpretation.
Yeah, this year they're really highly recommending all teams stay away from ejectable payloads due to some extra scrutiny that we're getting from Spaceport America, Tripoli, and other people that are really concerned
Insurance, you
about
mean?
it.
Insurance
Yep.
companies. That's what it all boils down to.
Yes, it is.
Yeah, it is. Yeah, okay.
So we got that. We got that. Fin flutter. What fin flutter analysis have you done for the rocket?
We use a software called FinSim. I don't know if you heard of it, and we just put the fins in, and then got the value it gave us out, and we are below that significantly, I believe. It's about, I think it's Mach 1.7, and we're going to just below Mach. On Mach even 8.8 or something.
0.8 or something.
We're going quite slow.
We're
so,
subsonic.
yeah.
Okay.
We've done. We also did a little bit of. Actually, this is just fins. We just did a bit of CFD for the force on the fins at an angle, and we worked out the forces, and then with the skinned fins, I think we were fine.
At Mach 1. We worked out the forces on the fins at Mach 1.5 at 5 degrees angle of attack, and that's all within testing margins.
Yeah, so that's what we basically with fins.
You also did some load testing on them as well, didn't you?
Yeah, that's what we mean with the forces.
Yeah, we did the CFD and then tested to that force. So.
Yeah, just hanging weights off the end of them, basically.
Yeah, off the tip cord, and then converting that into the mass, the force about the center of pressure.
Yeah.
Writing down a few notes.
No.
I think I'm running out of questions to ask here. Do y'all have any questions for me?
I know.
Yeah, we're gonna win. We're gonna win.
Yeah. I have some questions about frequency hopping.
Okay.
So they want us to. They say that it has to be. If we do frequency hopping, it has to be. Oh, I wish I had the exact wording. We need to be able to work with their system, but there's no details on what their system is, and it's. I just want to know what they wanted to actually provide.
So when it comes to that part, I know the guy that does it, but I have no idea what he does or how he does it. I would say for that, if you post a question on the HeroX forum, that would be your best way to get a response from them about exactly what they're looking for, what's needed, or why.
Okay. Can I ask, is frequency hopping common? Like, is the Cat Vega common? Because I know it's quite new. It's not really heard of over here.
It's a European computer, I think.
I know, but no one over here really knows it. I'm curious if it's a completely new system if anyone's ever done it before.
Yeah, I'm really not too sure on that one.
I've only ever seen one Cat Vega, and I was quite impressed with it.
That was ours.
That was ours, Colin.
That's the only one I've ever seen then.
Yeah.
You lose track when you get all these different universities.
Yeah, but if you're not getting an answer on HeroX in a few days, please feel free to reach back out to me, and I can poke them and get an answer if they're not replying.
Yeah,
that's great. Thanks.
What else you got for me?
Have you got anything, guys?
That was my main one. I don't know.
That's it for us.
I think that was it.
Igniter.
Yes.
Now you recommend. Seen a video of some guy making some dodgy stuff up in his back garden with slicing grain. See, we can't slice a grain; it's illegal in it's classed as an act of manufacture due to English law. So cutting a slice off grain to put onto an igniter is totally illegal to do in the UK. So how are we going to get around that? It's obviously illegal in America, but we won't have any pyrogen or any fuel to cut up to make these igniters. How do we go about doing that?
Yeah, good question. We've definitely had some ups and downs with igniter and different manufacturers the past 2 years, but I think we've got all that sorted out, and we do actually have, I think, 2 vendors that will be on site that will be selling igniters. So one option is we could get you in contact with one of them to make sure that you have a igniter ready for purchase when you arrive here.
Yeah, because it's like a double igniter and it's got big bits of AP hanging off it. because I can understand why. It's because they need to go on the first. You don't want to misfire on anything, do you?
Yes.
So they need to go on the first. So I can understand why they're doing it, but
yeah, it's definitely caused some headaches, especially when people aren't paying attention and don't wire them properly. Then they won't fire. But last year we had a pretty good success with the way we were running the operations out there, and I don't think that ever happened. We did have, I think, 2 igniters that failed for different reasons. But yeah, if you're worried about making igniters at all, we will have some on site. I can get you in contact with 1 or 2 people if you shoot me an email to make sure you have something here.
yeah, you don't want to go over there and it's like, oh, sorry guys.
Yes.
Just have to use a bit of twigs and light a small fire under it to get it going.
Right. And then also for holding the igniter up in the motor, if you have a very skinny piece of wood, honestly, like a 2 millimeter, maybe 3 millimeter piece of round rod to hold it up towards the top of your motor. And those are also items that, worst case scenario, let's say if you go out there and you accidentally step on your igniter, the pad managers out there will also have some spares just to make sure we can keep things moving as well.
Yep. Brilliant. Yeah, be an experience.
Live and learn.
Yeah, live and learn. I just need to get on their backs to stop doing all these stupid, silly exams that they're doing, and get some rockets made. Yeah. I mean, they've got the majority of it there now. It just all wants assembling, but with the British weather and just get to flying sites and exams and everything, just falls right at the exam season for us. So it's quite everything's packed in the last few weeks, isn't it? Well, we've only got what, 4 or 5 weeks, is it? Like
just
that.
about. Yeah. It's coming up quick.
Shouldn't have told them that. Look at them, they're all panicking now. I'll have to get them down to my workshop one weekend and finish it all off. Might be an idea, actually. That go through everything, get it all finished.
As well.
Yeah.
Right. Do you have any
That's
questions?
all I got.
Is that all you got? And
that's all I got.
How do you
for
feel
y'all?
about us then at the moment? Are we doing all right, or
Y'all seem to do all right. Of course, we would hope for a completed rocket, but I think y'all are just one step away from that. Just a few things to finish up the fins, the electronics, and put some rail buttons on, and ejection charge testing. So you're right around the corner from having that part done, and I'd say sit back and relax and wait for the competition.
Don't say
that'll
that
come up quick.
Just say, you need to really work hard every night of the week. No socializing, no drinking, nothing. No exams, nothing.
The harder you work, the quicker you work, the quicker it'll get done.
Yeah, it will.
The last part on that little checklist has some useful information. Please make sure to read over that. It has some good information for different areas, especially safety. I'm sure Ezra will be sending out additional emails as it comes, as they did last year, just kind of safety tips and reminders. Make sure to pay attention to those. Feel free to reach out to me at any time if you have any questions about the competition or anything in general. And if you can, like I said earlier, send me a picture of the av bay once you have it completed with the wire connectors. And if you could send me a participant list of everyone from your team that was able to join today.
Yeah, can do that.
Okay, perfect.
But I do want to thank y'all for your time. The rocket looks good. I'm excited to see y'all at the competition and see it fly.